Hey, good morning, everybody. Welcome to week 5. We are flying through this quarter. Let me screenshot the 4 participants. Cool. All right. How is everyone? Yay. It's Monday. We're so happy it's Monday. All right. Any questions?
I have a question.
Okay. Go for it.
So for the node, all I did was put in the definition of a node, like basically the pointer to yes or no, and also the string that holds the text.
Mm-hmm.
But what else do I need to put inside the node? Because I forgot.
About 1 million methods, but that's it. So a method for it depends how you want to set it up, but somewhere between the tree class and the node class, you're going to want a way to play the game. You're going to want a way to build the tree recursively using that ingest idea, and you're going to want a way to do a pre-order traversal to write the tree back out to a file. Those are the 3 main things. And those can be done, in the tree class or the node class, or possibly in a combination of both in the way we did binary search trees.
I think I did it on the tree node because basically the tree is going to be representing like the adding and so forth. The node is representing like, the definition of a node, like what is in the node.
Okay, cool.
While the tree is kind of doing the moving around the nodes and so on.
Okay.
Although I don't know if that's a good way to do it, but when I did a little test program, it did make a tree, so that's good.
So I will say, if it works and it makes sense to you, it's a great way to do it. That's kind of my general metric. Unless told otherwise, like if I say you have to do this in the node class, then that's that. But in general, if it makes sense and it works, it's good. That's the approach that I want people to take. You may also, want some way to tell whether the thing in the node is a question or an answer. Now, you can do that by checking to see if the yes and no are both null. And you can do that in code every time that you have that question. Or you could make a method in the node class that simply returns a Boolean whether both nodes are null or not. Or you could make a Boolean flag that is updated as the node gets created to record whether it's a question or an answer, or there's all kinds of ways you can customize this, but whatever makes sense to you and works, that's the one to run with. All right, let's take a quick look at the current ODP. So this posted and is due Wednesday.
I think I remember correctly, it was showing that it was due on tomorrow morning, I think.
Oh.
You might want to check that in case I'm wrong.
306 is due tomorrow. Yeah, tomorrow morning.
Okay, it should be Wednesday. I'll go ahead and change that. I try to set these things up carefully, but I have to set them up twice in parallel because the school won't let me merge my sections. So sometimes I make mistakes. The fun part is when I make mistakes, I make them twice instead of just once. So here's 306, and this is really just a continuation of 305, where instead of having 2 states for add or multiply, you now have 4 states. So this is a class called states2, and it's still got an internal integer that it's going to keep track of. Let's see, ODP 306 says it's due May 4th at 8 a.m. This one is, I only made this mistake once. Okay, so a class called states2. It has an internal result, which is just an integer, and you can read that back by calling the result method. It has a process method that takes an integer and performs silently an operation on the internal result. but this time the operation can be to either add, subtract, multiply, or divide. And pay attention, subtract subtracts n from the result, right? Subtraction is not commutative, so you've got to get the sense right. So if your current result is 10 and you process 1 and you're in subtract mode, then the current result would be 9, right? Subtract 1 from the result.
Question.
Yeah.
What should result default to, or before it's ever set?
Defaults to a 0.
Okay, alright, thank you.
Yeah. Alright, and that is due May 4th at 8 a.m. I just updated that in Canvas. Alright, and then there's a do-op method that takes a string, and the string is either add, sub, mul, or div, and it sets the mode of the system accordingly to be addition, subtraction, multiplication, division. Default operation is add.
At first I thought do-op was a typo for some reason.
Oh, yeah, it looks funny.
So, but I do have a question about this. I already did it, but I was kind of curious about what your thought about this is. When I was creating the state method, like just a variable for determining what state you're in, I use integers from like 0 to 3 to represent 0 for add, 1 for subtraction, and so on.
Cool.
But I was wondering, like, just to practice good programming habits, is that a good way to do in state?
I think that's a good way to do it. The one thing you might want to do is create some symbols, right? So you could say, like, integer add equals 0, integer sub equals 1, mul equals 2, div equals 3. And then, you could set your state. If you see, like, do-op add, you could set your state equal to, instead of setting it to 0, set it equal to ADD, which is hardwired to a 0. And if you get, a div, then your code could say, set state equal to div. And then in your process, right, you could switch on state, and you could have case add, blah, case sub, blah, just to kind of avoid having too many magic numbers floating around in too many places, right? Now this is a pretty short piece of code, so if I just say 3 is going to be divide, as long as I put a comment somewhere saying, state 3 means divide, I can put a 3 down here, I can put a 3 in here, everything will work out fine. But in a larger program, sometimes we would create, variables. In C, we would use pound defines, for example. And then, every time that we mean division, instead of having to remember it's a 3, we could use the symbolic name div. And so that's just kind of a programming trick thing. All right, up to 7 people. All right, so modify your previous state version to have 2 more states, and test your code on some sample code. And when you're done, go ahead and assess in the usual way. And we got a few 10 out of 10 so far. 3 people. Cool.
I kind of feel like ODPs are kind of like an in-class activity thing.
Yeah?
I remember like remember doing my English classes that there's some kind of activity we did. I don't remember what it was, but it was like it took like an hour long to do the in-class assignment.
Okay. Yeah, ODP should be 1 day, but Tuesday, Thursday, Monday, Wednesday, I'm making them 2 days. But hopefully these are just sort of good touch points to keep you coding. I mean, I'm giving you 2 weeks for PA4. For PA3, it doesn't necessarily take 2 weeks, but it takes more than a few days. But, you know, if you're leaving it till the end, I don't want you to go like a week or two without writing any code. So ODPs are a way to sort of keep coding. Ideally, you're coding every day, right? I mean, it's like practicing a musical instrument or working out or whatever. It really should be a daily practice. And you know, your benchmark goal for things is 10,000 hours, right? So if you code for an hour a day, that's going to take you 10,000 days. That's like, you know, 30 years to reach that.
Hours.
Yeah. So if you can code 5 hours a day, right? That's 2,000 days. You'll get there in, you know, 6 years. Which is
10,000 hours for what exactly?
so there's this rule of thumb benchmark, 10,000 hours of whatever to become an expert at whatever. So you want to get really good at guitar, practice guitar for 10,000 hours. So you want to get good at coding, code for 10,000 hours. It's just kind of a random rule of thumb. It's a good title for some books and such. But, you know, it's nice to have some sort of metric in mind for, you know, how many hours of programming have I done, and how many has, you know, somebody else done. What does that actually mean? I don't know. But certainly if you're coding an hour a week, right, there's probably only a certain level of proficiency you're hit. If you're coding, you know, 5 or 10 hours a day, you're going to improve rapidly, right? And few of us are in a situation where we have the luxury of coding for 5 or 10 hours a day. That would be a very unusual situation in 2022. But, you know, the more you can code, the better. And so ODPs are a little bit of, you know, some extra code you can write. But ideally, you know, if you have projects of your own that you're working on, things that you're interested in, that's your best source of ways to practice programming. And that's where you get into all the weird edge cases and where you develop the habits and you get the really good hardwiring for how to do things, and things become second nature and so on. And you know, in between quarters, over summer break, in between Clark and university, right, you definitely want to keep coding. And more, the courses you get into will just hit the ground full speed, right? So you'll get into a university course and you probably won't spend, you know, a week or two doing Hello World in some new language. So one of my favorite classes, right, the first class, our homework was learn Pascal, right? And we had to learn this programming language so we could start using it for our assignment in the next meeting. And that was great, you know, because I didn't want to spend time in a class going through syntax and coding examples and stuff like that. It was like, learn this language, right, and next time we'll use it. But that takes a lot of time on your own, and I understand that's challenging for most of us because of, you know, jobs and life and all of that stuff. All right. So different topic, class extensions. So you've heard me say some grandiose things like everything is a class, right? Which is sort of true in Java, except for primitives. Another grand statement that you'll hear people make is everything is an object. And there's a class in Java called object. And it doesn't do much, but it says object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. What does all of that mean? So we've also said, you know, Java object-oriented programming in general is largely about code reuse. It's about optimization. It's about streamlining our development process. And so the idea is, you know, if I have some class named rectangle, and I've got, you know, some stuff I want to put in there that stores information about the dimensions, and maybe it stores the color of the rectangle, and maybe I store a date when a rectangle was created, and maybe I have a method for comparing two rectangles to tell if they're the same, and I have my area and perimeter methods that we actually wrote, and so on and so forth, right? And maybe I've got another class called ellipse, and it's got its own stuff going on, right? It's got a major and a minor axis, right, which are kind of like, you know, the width and the height of the ellipse. And it's got its own way of calculating area and perimeter and so on. But maybe it's also, maybe ellipses also have colors. And maybe there's a way to compare two ellipses and tell if they're the same thing. And maybe I've got another class called, you know, hexagon, and it stores 5-sided polygons and so on. But a lot of these might have things in common. For example, they might all have a way to compare internal measurements to see if two of these things are the same. They might all have a way to store a color of this this particular object and so on. And so I might define a class called a shape. And in this class, I might put in some of the methods or fields that are common to rectangles and ellipses and hexagons and all these other shapes that I might define. And if I define all of those things inside this class, maybe I don't have to redefine them inside these other classes. Maybe there's a way to say, hey, a rectangle is a shape, but it's a shape with some extra stuff going on. And maybe when I get around to defining a class called a square, you know, most of the stuff I do in a square is the same stuff I do in a rectangle. I've got a height, I've got a width, I've got an area which is their product, I've got a perimeter which is twice their sum, and so on. So a square really is a rectangle, but with one extra feature, which is the length and the height are always the same. But you know, if I took everything that was in the rectangle class and I just changed the constructor and said, hey, your constructor takes a single number and that becomes both the length and the height, right? I wouldn't have to recreate all the stuff that I put in the rectangle class. I wouldn't have to rewrite an area method. I wouldn't have to rewrite a perimeter method. I could just say, hey, you know, I want everything that's in a rectangle class, but maybe I want to change my constructor. And say, hey, the constructor takes a single number. Or the constructor takes two numbers, but they have to be the same. And I'll throw an exception if they're different. And so what we're going to see is that sometimes we have a hierarchy of classes where a square might be a particular type of a rectangle and a rectangular might be a particular type of a shape. And a shape might be a particular type of a something else. So if we follow this hierarchy all the way up, what we find at the root is always an object. And every class we create is really a version of this object class with some extra stuff thrown in. So when I make a rectangle, it's already got a toString method. Because a rectangle is an object, and objects have a toString method. Well, what does this toString method do? It prints out, you know, rect colon and some hex number. It also has a clone method, an equals method, a finalize method, a getClass method, and so on. But you know, when we made our rectangle class, we made our own version of toString. And then when you tried to call a rectangle's toString, it used our version instead of this default toString that it inherited from the object class. Alright, so this is the notion of a class extension. So basically we can define a base class, sometimes called a superclass, and we can say something like this. Class square extends rectangle. That's the keyword, I should write it neatly. Extends rectangle. And then we can put a bunch of stuff in here. Okay, this is called a superclass. Ironically, it's sometimes called the base class. We'll usually call it a superclass, right? And it's basically saying, hey, I am defining a class called square. That's the name of this class. But I don't want to begin with just an empty class, right? I'm going to begin with everything that you find in this class named rectangle. But I might add some extra stuff in here. And I might change some of the stuff that comes from rectangle to do something different. For example, I might change my toString method. Yeah, go ahead.
So it says extends. Does that mean, is it kind of like that you're taking the entire code from the rectangle class and it's kind of like calling it into this class?
Yep.
I don't know how to phrase it right. But
So we're taking all of this stuff that's in a rectangle, that's all in this class already for free.
So then there is the question of like, what syntax would you use to like call something from a rectangle class into square? Can you give me some examples?
Yeah, let me get up to that. Let me work up to that in a few minutes. So to begin with, we're just going to extend this rectangle class, which means all the stuff in here is available in here. We can add more stuff in here. So we could define new fields and new methods that are not part of rectangle, but are part of square. Or we can override methods or fields from rectangle, for example, the toString method. We know that toString prints out, this is a such and such rectangle. We could modify that and say, hey, this is a square with sides equal to such and such. And so yeah, let's do some code. And let's grab some rectangle class. I don't think my rectangle directory has anything in it. Okay. I'm just super lazy, so I didn't want to write my 34 lines. Alright, so here's a rectangle class. We've got a constructor without the annoying message. So we save the height and the width. We've got a toString method. We've got an area and we've got a perimeter. Alright, so that's our rectangle class. So let's make a main method. And I want to use a square class. So I want to construct a square like this, and then do some analysis. So I want to work with squares. I'm going to construct a square with a side of 10. I'm going to print it out, and then I'm going to use the area and perimeter methods. And so let's make our square class. Well, we could do this the way we did week 1, right? But instead, we're going to say class square extends rectangle. So when we do that, our square class is going to contain a pair of integers, height and width. It's going to have a toString method, an area method, and a perimeter method. So let's make a constructor. So it takes a single argument, which is the length of a side. And let's do this. So we'll set the height equal to the width equal to the side. Now I haven't defined height and width inside this class definition. But because a square extends a rectangle, and a rectangle includes a height and a width, right, this should be a valid statement. Unless I'm having a Monday moment. So let's see. Oh, this is a goofy thing though. Yeah, hold on a sec.
Question?
Yeah.
So C has JDB to debug it. What does Java have?
JDB.
Java has JDB?
Yeah, like the Java debugger.
Oh, and is it already in the Linux system, or do you have to do something that already different?
It's usually part of the Java development kit that you download.
Are you going to show us a demonstration of that sometime soon?
Probably not.
2 minutes for debugging really big programs.
I don't find JDB to be terribly useful, and since we're moving into Eclipse, the debugger in Eclipse is very useful, so we'll probably stick with that.
Okay.
JDB feels to me like something that's supposed to be put inside a wrapper, like Eclipse. But I mean, it's the same as any debugger. You compile with a -g switch. You say JDB and the name of the class file, and then you can step, you can put in breakpoints, you can print values, and so on. But it's very picky. And you have to, you can't just say break at this method. You got to tell it what class and what method, and maybe a signature, and so on. And the debugger in Eclipse, very painless to use. So we'll be playing with Eclipse later today also, and we'll see some of that. All right. So I we'll talk about using constructors from other classes later, but I just lowball this and just assume that rectangle also has a default constructor. So our square class looks like this, right? I define a constructor that takes an integer and it just sets height and width equal to that. And if I compile my main program and run it, right, this works great. This is a 10 by 10 rectangle, the area is 100, the perimeter is 40. Alright, so, yeah, let me turn up my volume.
Just a patch. Like,
All right.
not just one.
Okay, that should be up a little bit.
Yeah, it's better.
Cool, thanks. All right, so this is good, right? We did not have to define an area method or a perimeter method. We just said this is an extension of a rectangle. So the stuff in the rectangle class that makes sense is still available to us, including the height and the width and so on. All we had to do was define a constructor. But the toString method says this is a 10 by 10 rectangle. We really wanted to say this is a square, right? So what I can do is override the toString method from the superclass. So my toString method in my square class is going to return a square with sides of length, and I'm just going to tack on the width. The width and the height are the same. It doesn't matter which one I use. So now I've got a new toString method, and so if I compile this and I run it, it tells me S is a square with sides of length 10. But then for the area and the perimeter methods, I just used the ones that were supplied by the rectangle class. So this is calling the constructor in the square class. This is calling the toString method in the square class. These are calling the area and perimeter methods in the square class, but that were inherited from the rectangle class, right? I didn't write area or perimeter in here. They came from the fact that this is an extension of a rectangle. Now, if for some reason inside this class I wanted to use a method from the rectangle class, let's say I wanted to call the rectangles, I don't know, some method from inside there that I didn't want to write, but I was going to override, I can use the keyword super. So, so there's a couple of keywords here.
Well, before you continue, I have a question.
Yeah.
So I have three questions, just out of curiosity. Can you put arguments inside the extended or superclass, if you call it? And
Can you ask that differently, maybe?
well, in the superclass, can you add arguments into the superclass or arguments inside the class, kind of like you did with just one class?
So classes don't take arguments, but methods in classes, yes, you could.
Well, it's not arguments. It's something like parameters or something that it passes.
I think he means for the constructor.
Are you talking about the constructor in particular?
Not exactly, but maybe
The constructor is the only thing in the class. When you make a class, you can hand it arguments to the constructor.
Right.
Which would be, I guess, handing a class an argument in some sense.
True.
Mm-hmm. Okay.
Anyways, he did this right there. If you look up at the top, he's handing. Oh, no, he switched.
You switched.
If you look there, see public square inside. This is an extended class, and he's handing an argument.
Well, I know that. I was just kind of talking about, I don't know, remember he was doing some kind of class, making some sort of main class, but he's able to pass a string to the class or something like that, but not to the constructor, but to
Like a method?
The class.
So yeah, you can pass whatever you want to whatever methods. And
I know that.
Okay.
But you know what? Never mind. Maybe I'm not thinking correctly on this one. But I do have another question that's better. So can you extend more than one class, like make two superclasses, or is it just one at a time?
I don't think Java lets you extend more than one at a time, and that's one of the points where a lot of people dislike Java. I don't think it does multiple extensions.
Okay. Alright, thanks.
But this will work for us. So if your question becomes clearer as we go through, definitely go ahead and ask again, because we'll play with a bunch of different aspects of this, and it may answer your question or it may make clearer what the question is. All right, so we can call a class from the perspective of the person calling this. We have no idea that square was an extension of a rectangle, right? Just like when we look at the documentation for a linked list, for example, right? We don't really know or care that a linked list is an abstract sequential list, or that an abstract sequential list is an abstract list, which is an abstract collection, right? We just see the documentation for this and we say, hey, here's the methods we can call that are part of linked list. But if you go further down this list, for example, there is no isEmpty method inside a linked list. But if you go down, you can see methods that were inherited from these other classes. And from the java.utility.list class, there's a method called isEmpty. Well, since this is an extension of a list, there's an isEmpty method that we can call on a linked list. But it's not actually part of the code. If you looked at the source code for linked list, it wouldn't have an isEmpty method. But it would extend, another class which itself implements an isEmpty, or was an extension of something that has an isEmpty, and so that's available to us. And so let me rephrase the question of multiple extensions, right? We can't say that this class extends two different classes, but we can say, class A extends B, and B itself could be an extension of C, and C could be an extension of D. And so, our class would be an extension of B and C and D in that sense, but it's a hierarchy. It's not like, we extended two classes side by side.
So basically, in a nutshell, if A extends B, then B is now a child class of A.
The terminology is a little peculiar, but if we say class A extends B, we usually think of it like this, right? And if class B extended C, then C is up here. And ultimately, everything is an extension of object.
So yes, but the other way around.
Yeah.
Gotcha.
Okay, and parameters for generics, different creature. But they would work the same whether we're extending or not.
Oh yeah, I was thinking generics.
Okay, yeah, you said parameter, but I didn't pick up on it.
I didn't know I forget what it's called.
Yeah. All right. So class extensions are useful in general in object-oriented design, and it's how a lot of the different classes we have in Java are created. So the linked list, for example, is a collection with a few extra things added in. This is going to be topical to what we're doing for the rest of the course, playing with graphical interfaces and swing and so on, because we're going to be creating our own windows. For example, we'll want to create a window with a title bar and an X button and a dash button and a plus button and some icon up here, and then some area here where we can put buttons and drop down lists and radio buttons and so on, right? And when we do this, we're going to want very particular characteristics to our classes that create these things. But we're not going to write all the code that we need to define a class that can draw this window, or to define a class that will make this picture of a button that we can click on that will do certain things. Most of what we want these things to do, there are already classes that will do those things for us. This main thing up here is called a JFrame. This area in the middle that we can drop components in or we can do drawing in, this is called a JPanel. These are swing components. Swing is a package of classes. This is a class, that's a class. Most of what we want to do in a drawing area is already available for us in this class, but we may want to customize a few things about it. Just like we customize the toString method in a square, without rewriting all of the stuff in a rectangle, we just said square extends a rectangle. Well, we'll create our own panel, my panel, and we'll say my panel extends JPanel, and we'll just make a few changes inside my panel for the things that we want to do differently from what a default JPanel does. This is going to be how we end up doing graphics. We'll mostly override one method called paint. And paint will be the thing that draws, you know, shapes on our screen. So we'll be using these ideas in very particular ways. But I wanted you to see this idea of class extension, and I also want to use this to introduce a pair of keywords, super and this. So super is the easier one. Suppose class square extends rectangle, so all the stuff in rectangle comes into here. And suppose there's an area method in rectangle, and we want to write our own area method. I don't know why we would do that, but some method in here we want to write our own version. So we can override the method from here and write our own version. Let's say it's a method called blah. Right? So blah paren paren. And this code, you know, if we're in this class and we say blah, it's going to run this code instead of the blah code from rectangle. Right? So this is overriding the method from the superclass in this class. But if for some reason, you know, we wanted to run this method from the rectangle class, we can use the keyword super. We could say super blah. And instead of running the code we wrote in here for a method named blah, it would run the code from the base class, the superclass, rectangle, named blah. So super.blah lets us get to the fields and methods in the superclass.
Question.
Yeah.
Is this the secret to basically doing for just compiling the one file for PA3 instead of multiple ones?
I don't think this really kicks in much in PA3. The secret to compiling one file is just kind of what Java does for us when we compile a main program. If it doesn't find class files for the things that are being called, it will look for .java files and compile them for us. But that's really just kind of a convenience of the compiler.
Never mind.
Okay. Alright, so super is a way to get to the superclasses, methods, and fields. That's not a really bizarre one. The really bizarre keyword is this. And this is the ego. It's the sense of self. And you never really need to use it until we get into some weird situations like in PAs 4 and 5. But let me tell you about the this keyword. And English is an unfortunate language because we're going to talk about the this keyword, or this, or this other this, or things like that. It's a horrible thing to try to talk about. I should just rename it Purple Bunny or something. But let me give you some examples. Suppose we have a class called my class. So we have a class, my class. And somewhere in here, we say this. Maybe this dot some field or this dot some method. Let's pretend there's a method named code. All right. Let's suppose that you have a program and you construct an object, my class, bunny equals new my class. Let me make a piece of code in here. Public void code. And suppose somewhere inside this code I have the keyword this. Alright, so I make a class called bunny. It's a new my class. Let's make a second my class. Bird equals new my class. And let's suppose that somewhere along the way I call bunny.code. Alright, so what happens? Bunny is an object of type my class, so inside my class the system looks for something called code and it starts to execute it. When it gets to the keyword this refers to bunny. As code is executing, if I have the keyword this refers to the object named bunny. It's the version of I, right? Me. It's the object that was used to run this code. Whereas later on, if I were to say bird.code, code starts executing. Now the keyword this refers to bird. So
I think I know what it is.
okay, so
I seen like sorry, I was
go ahead.
thinking, don't understand it. So this is, I hate English too. So this, the keyword this is kind of referring to the class itself. So if you want to, so you can say this dot another method, correct?
Basically, yeah, this is referring to the object, right?
Yeah, not a class. But
Yeah.
Wait, that's kind of weird to me.
Yeah. So if I say bunny.code, this is bunny. If I say bird.code, this is bird. It lets the code inside here kind of know what object was used to run this code. And that's not going to be important for PA3 either, but it will be important in PA4 and PA5. And the one place that you see this sometimes is for constructors. And it's not necessary in there, but it's useful. Yeah, go ahead.
So what's the difference between when you're inside the class running this code versus can't you just run code?
I wouldn't run this code, right? That's why I crossed that out. But if I needed to know what object was used, I could use the keyword this.
But couldn't you just run another function just by typing the function name in?
Yeah, we haven't really explained why we care about this.
Okay.
Right? Why would this code need to know what object it's in? But I'll give you an example of that right now. And it's not a super critical example, but it's an example nonetheless. So yeah, go ahead.
Is the keyword this considered a class, like a class itself, or an object?
It's an object, basically.
So, yeah, can you show a document of the keyword this?
Show you a what?
A documentation?
No. I don't know where I would find documentation for that keyword.
Oh. Okay, I thought maybe.
Really? There's no like man or like Oracle docs on the keyword this?
I don't think it's listed in the list of classes because it's not a class, but you could find it in any documentation on Java. We'll talk about the keyword this. So here's an example of this, right? This. We have our rectangle class, and we have a pair of fields, height and width. When we made our constructor, notice what we did. We said the arguments are called h and w. Well, that's not horrible. H pretty much means height, and w really means width, right? But you know, you don't want one character variable names. You get zeros on some assignments at university if you have variables with only a single letter in their name. So really, you know, what I should do is I should call this height, and I should call this width. And then this should look like this, and this should look like this. That would be cleaner code, right? Because now clearly my first argument is the height, and my second argument is the width. But these statements are no-ops, right? Saying height equals height doesn't do anything because height refers to the thing most closely scoped, which is the argument listed right here. So this is taking this local variable height and setting it equal to itself. Well, that doesn't do anything. And in particular, these assignment statements have no impact on this height or this width. What I really want to do is take the height field of this current object and set that equal to height. So this is where I can use this. I can say take the current object, set its height field equal to, well, height right here means the argument that was given to the constructor. But this dot height means the height field for the current object, which is this thing right here. And so this is the way you would usually see a constructor written. Your arguments would be, you know, what you want them to actually be called. And then the assignment statements would say this dot height equals height, this dot width equals width. Does that make some sense?
Yeah, I was wondering maybe this might be a better alternative to making global variables or something like that.
Yeah, and this is a better alternative to calling this, you know, h and w, or underscore height underscore width, or height argument width argument, or a and b, or I and j, right? And it's in this form, right? This is not doing anything we couldn't do other ways by calling this, you know, height argument and width argument. But this is a very clean way to say, hey, this is an argument, right, height. This is a local variable inside this method. This is the height field of the current object, right? And so let's set that thing equal to height. So that's all that's going on there.
Okay, question.
Clarification, documentation on this is not hard to find. It's not obscured, it's not hidden. But the only documentation I've shown you in this class is this API documentation, right? The list of classes that make up the application programming interface. And this is not a class, right? So I can't search in here for this. I mean, I won't find it in the index, I believe. We could try, though.
Fair enough.
Maybe they put it in there. But it should be in the textbook. It should be in the Oracle documentation. And it's in the lectures now. But yeah, if it's not a class, I don't think it will show up in here. But I don't want to make it sound like it's mysterious or anything.
I just saw it, by the way. Yeah, I just saw it right pretty close. If you go back and just search.
I didn't. I saw it skip from E to R in the third one. Oh wait.
Yeah, these are different things.
This object and this.
Yeah.
Object. Okay. That's close though, but it's not it.
That's close. All right. Someone else had a question.
Yeah, so say you were in, say you called the function area,
Mm-hmm.
and you wanted to run the parim function from inside that for some reason.
Mm-hmm.
You could either do this dot parim,
Mm-hmm.
or just run parim.
Right. Correct.
What would be the difference between those two?
No difference. And I don't think you'd find a case where you said this dot parim, because the only parim inside here is the parim inside this class, right? So parim would always be the same as this dot parim. For fields, right, like height and width, we have different scoping. We could have a height that's local to this method, right? I could say, you know, integer I, and then if I said this dot I, that would refer to a variable I defined as part of the class. But the more important use for this is when we really want to know what object are we in. And sometimes, you know, we're going to run a method in an object, and the method is going to want to call a method in a different object, but let it know what object this call is coming from. And so you might pass this as an argument to another method, and that's the version that we'll see in the assignments at the end of the course. And until then, it's kind of, you know, a way to make your code a little less kludgy in constructors, and that's kind of it for now. All right, good enough for now?
Yeah.
All right. Let's play with some swing. So JFrame is a class. And it comes from javax.swing. That's what we call a package. We'll still talk about packages later. But a JFrame is a type of frame, which is a window, which is a container, which is a component, which is an object. And a JFrame is basically this visual element that, you know, gives us a little rectangle that we can move around and resize and maximize and minimize and close, and that will eventually contain buttons and drop-down lists and all kinds of good stuff. We can construct it by just saying JFrame, or we could say JFrame and give it a title that we want to have in the top of the window. And it's got a bunch of methods. And, you know, not too many methods in the JFrame itself, but a lot of methods that get inherited. So all these methods, these are things we can run from a JFrame. And let me start with a really simple example. So we need to javax.swing.jframe. Yeah.
So when you call a method inside of, I don't know if you want to call it a parent object or parent classes, but can you actually imagine, this might sound really weird, but can you call methods from previous classes that's been inherited, just normally you would do with the class that you imported?
Not sure I know what you're asking.
So, like, because you imported a Java Swing JFrame, but you constructed it, right? And you called it the variable s. Can I do like s.add? And add is a method inside of another class that's been inherited.
Yes, absolutely.
Okay.
Yeah.
That's what I was asking.
Yeah, that's the whole point of inheritance, is that since a JFrame extends a window, any methods that are available in window are also available inside a JFrame. So all of these, unless they get overridden. All right. So let's just construct a new JFrame. And we'll call it this thing called mainframe. So that compiles, and if I run it, not much happens. It runs, it exits. Implements is for interfaces usually. Alright, so this doesn't do much, right? It constructs a JFrame, but by itself not much happens. So what we really want to do is this method inherited from window called setVisible. And setVisible takes a Boolean. Welcome. If we call setVisible and we pass it a true, then this window will become visible. I should not have called this uppercase. So I'm going to construct a JFrame called mainFrame, then I'm going to call the setVisible method and set it equal to true. And when I run that, well, it's a little hard to see because it's on my other window. But let's see if I can drag it over. I've got this tiny little window that appeared on my other display. And this is a JFrame. And I can grab a corner and I can extend it, and you can see it's a whole window. And the upper left corner has the little Java symbol, kind of a penguin with a red nose. And I can maximize this, and I can demaximize it. And ultimately I can close it. And my code is still running, right? But, you know, we created a graphical element there, which is pretty cool, and we did it with 2 lines of code. We constructed a frame and we called the setVisible method. Alright, well, there's another method.
Is there a method actually for, like, if you press close, it would stop the code?
Yes.
I mean, it's kind of common sense that you should exist, but like...
Yeah, we have to actually set it up, but we can do that. So there's a set size method. So we can set the size to be, I don't know, 300 by 400. And if I run this, I get a bigger window. And it's by default, it's sitting at location 0, 0, which is the upper left corner of my other display. Right, so that's something I can't easily show you. But there's also a set location method. And you know, there's different signatures, so I can specify set location with a point, and a point is a different type of object that basically has an XY pair of fields. Or I can call set location with a pair of integers, XY. That does explain some things about Java, doesn't it? So let's see if I can get lucky with the location. So we'll go with 4,000 and 0. So I'm going to create a JFrame, make it visible, set its size, and then set its location to be 4000x. And, well, that didn't work. I'm just playing. Ah, okay. There we go. So 0, 0 is actually display 2. I switched my displays around. Alright, so now I run my program and there's my Java window. And in my constructor, if I pass an argument to it, which is a string, right, my window has a title to it. So, so this is, you know, simultaneously not very exciting, but super exciting, right? A few lines of Java code by using a class from this package, and we can get graphical elements to display. And that's pretty cool. That's a fantastic start. So let's take a 5-minute break, and then let's hop into Eclipse. We can do this from you know, just plain old VI and Java C, but we're going to do this from Eclipse. And in Eclipse, we're going to be able to use Window Builder to drag and drop. And I want to start looking at some of the things we can do. We did a little bit of this really quickly at the end of class Wednesday, but let's put some buttons down and connect some actions to them and so on, and then we'll start building from there. And this is all lead up to Wednesday when we'll talk about PA4, which will be a graphics-based game that we're going to develop. So let me go ahead and do a 5-minute break. And
I got a question for you.
Yeah.
So you know how in Bash there's the dialogue, I think function or feature or whatever.
Yeah.
And you can make a calendar and input boxes and stuff.
Mm-hmm.
Can you do the same thing in Java with JFrames or something?
Sure thing. Yeah. Now the package we're going to go over, Swing, these are low-level building blocks, so a basic frame, buttons, radio buttons, checklists, drop-down lists, menu bars, things like that. You could design your own, you know, calendar interface that would show a list of dates, and you could click on them and so on. And these things already exist also. They've been written by numerous other people. But this will give us a much more controlled way to make graphical interfaces, to do drawing, to interact with the user, and so on and so forth. And it will make dialogue look really, really crude. So this is going to be much more powerful. And a whole lot more fun, much less guesswork. Alright, so I'll see you back in about 5 minutes.
Okay.
Uncle. All right, welcome back. SLPs, let's talk about questions offline maybe, but in general, your SLP does not have to be unique. It does not have to be, terribly original. It does not have to be better than, other solutions that are out there. It has to be something that you're interested in working on and that you learn stuff in the process of working on. And, it's a learning experience, school experience. If you're making something and it turns out somebody else has done this also, that's totally fine. It does not disqualify it in any way. But if there's more specific concerns, we can definitely talk about it. All right. Well, let's get to the good life. I'll put this code over on the server anyway. Alright, so I've already downloaded and installed Eclipse on my system. Hopefully everybody else has done this and has Eclipse running, and you can play along while we're going. So I'm just going to start a new workspace for CSE223 Spring 2022. And so here's my basic window. I have no packages in here. I'm not going to use the outline area for now. So this is all, customizable. You can move these windows around and open and close them and look at different windows and so on. One really good thing to know is perspective. Open perspective. You can go to the default perspective, Java default. And if you change things around, if you close out your windows and stuff like that, you can always get back to your default view by going window perspective, and you can either reset perspective, which will bring it back to the way it was in the beginning with all of these, or you can go into perspective, open perspective, other, and you can do Java default. If you want to debug, basically just window perspective, open perspective, debug, and it'll take you into a debugging environment. And it's mostly self-explanatory, but we're not going to play with that for now. We're just going to stick with the default. And let's repeat what we just did. Let's make a JFrame that opens up and that we can interact with. So I'm going to say file, new, Java project, and I'm going to call this GUI1. I'll make it all uppercase, GUI1. Alright, uncheck this box down here. It's a default that does us no good. Leave everything else the same. I'm going to specify Java. I don't know if my Java's set up correctly or not. I should have. that should say Java 11 for you. Stick to Java 11, but I cheated when I installed this. So just take the defaults, right? Put in a project name, uncheck this box, go ahead and finish. All right, so now we can create classes, and normally we could say, you know, right-click, new class. But instead of doing that, I'm going to say other. And oh, I haven't installed anything on here. Interesting. All right. Well, we get to do the thing that we did quickly last week, which is install new software. So let's go ahead and go under Help, install new software, work with, and pick that first entry, 2022-03, and let's search for swing. And I'll just check all of them and say next, and say next, and accept the license terms and say finish. And it'll have me reboot. There's our 49% progress down at the bottom. I'm going to play around with this a second and make sure my Java setup is correct. Okay, so I'll go ahead and restart Eclipse. Yeah, I love that message from Eclipse. The installation process is taking longer than usual. That's in case you've lost track of time. All right, so let me close this project. So we got to install one more package. So install new software. Will come from here, and I'm going to do window builder, and I'll pick all of those. I'm going to delete this package while I'm here, so I'll delete. I'll wait for this to finish installing. Waiting. So let me tell you a preview of where we're going here. The big paradigm shift here. The big paradigm shift here is going to be to what we can think of as event-driven code. And normally when we write, go ahead and let that restart. Normally when we write code, we write a main program and we go, you know, do this, check some condition and either start doing these things or do those things, and then maybe go back up here and do these things again, and so on and so forth, right? Normally the code that we write is very procedural like that. And instead what we're going to start doing is writing code that responds to things that happen, right? Events. So most of our code is not going to be sitting in a loop anymore. It's not going to be, you know, while more input is available or while this flag is true. Mostly our code is going to be asleep. But before we go to sleep, we're going to set some alarms. And we'll set alarms such as when this button is clicked, wake me up. When the window is resized, wake me up. When the window is closed, wake me up. And then we'll go to sleep and we'll wait for these events to happen. If you've done Engineering 270, the lab with the 3 lights that keep blinking, and you have interrupts that can change their behavior, that's what we're doing here. It's interrupt-driven code, but the interrupts are typically software events. Clicking a button, things like that. And one of the big challenges for PA 4 and 5 is getting into this different mindset. From the idea of procedural code where we're laying out do this, do this, do this, do this, do this, to event-driven code where we basically do nothing. We just kind of sleep, but we set things up. So if somebody clicks this button, do these things and return. If somebody types something in this box, do these things and return. These are like interrupt handling routines. And we're going to have to think about our code in terms of how can we do what we want to do in this event-driven manner. How can we do what we want to do by responding to things that have occurred? And it's a totally different way of thinking about algorithms. And for working with, you know, writing apps for phones or interfacing with other systems or making games or things like that, this turns out to be a really, really natural way to think about programming. One of the events that we'll respond to sometimes is simply the passage of time. We'll say after a millisecond has passed, let's execute these statements. And maybe what these do is update the position of some object that's moving according to some physics model. And when the person hits the X button on their controller, let's run this set of code. And that, you know, changes the player's position and updates the display, and so on. So event-driven code is going to be very natural eventually. Alright, so let's try this again. Let's make a new Java project. I will call it GUI2. I will already uncheck that box. Take all the other defaults. And now I'm going to right click. And I'm going to say new, but instead of saying class, I'm going to say other. And over here I'm going to come down to window builder. Expand that, come down to swing designer, expand that, and I'm going to say JFrame. And I'm going to give it a name like, you know, main. And I'll just say finish. Alright, well, we got a fair bit more code than what we wrote in our first foray into frames. But you can see there's a public static void main up here. Here's where we created a frame, but we didn't create a frame, we created a main. But main is declared as an extension of JFrame. So it says public class main extends JFrame. So when we construct a main, we're constructing a JFrame, but it's actually a JFrame with some extra stuff. So this is a class extension. And here's where we do the set visible business. So we set the frame to be visible so we can see it. And down here, right, so this is a method that's actually a constructor. Right, so our class is called main. Here's the default constructor. So when we construct the main method, this code gets executed. Well, this first statement, set default close operation, that's what says what should happen when we hit that little X or an Alt F4 in the window. And the default operation is exit on close. And then we're calling the setBounds method, which sets the size and the location of the frame. So this is a location and a size. And then some other stuff happens. We create a JPanel called content pane, and we call a method called setContentPane, and all this other stuff we don't really care about right now. And all of this stuff up here is sitting inside a method called run. And it's in a try-catch block, and we don't have to worry about all of that stuff. There's a lot of heavy things going on here. There's inner classes, there's threaded operations, there's runnables, there's all kinds of stuff. I'm not going to worry about it. All right, all we did was create a new JFrame, call it main, And that's enough. If we go ahead and run this, we've got our window. And it's sitting at 100, 100. That's the XY location. And it's got a width of 450 and a height of 300. That's what these specified. And let me make my window a little smaller. Alright, and if I hit the X window, that will terminate my program. So I can put a print message in here. And now if I run this, I'm always going to save my resources when I launch. Right, I'll get my hello message out here, and this is the console view, right? And there's a little play button here. It's red, that tells me my program is running. If I wanted to end my program, I can hit that red button, and that closes my window because my program has been terminated. That's like the Control-C button. But in this case, if I hit the X window to close this window out, that'll also terminate my application. It tells me it's terminated, and it gives me, you know, a grayed out button. Or if you don't like point and click and you like keyboards, if I do Alt F4, that'll also terminate. That's how you close a window without a mouse. Alright, so there's a JFrame. That's GUI's 101, right? And we didn't write any of this code. We just, you know, went through a little wizard and clicked a few boxes. Alright, so there's a pair of tabs here. This says source, this says design. If we click on the design tab, this brings in Window Builder. And what we'll see is a picture of our JFrame over here. Eventually. And let me move this around a bit. Except it's not working. Alright, so when I did this last time, we set this up under VirtualBox. And then I tried actually setting this up on my default setup, and I didn't try closing that loop. So this may be flaky, and I may have to go back to VirtualBox. Because I'm getting exceptions from Window Builder. A null pointer exception, yeah, this is not good. This is a great sounding message. A terminally deprecated method in Java language system has been called. Please consider reporting this to the maintainers of Window Builder internal core designer plugin. So that's freaky. Alright, so I'm going to pretend that I listened to my teacher and I did this ahead of time. I think this is on par with Zoom saying internet connection is unstable. Alright, I'm going to do Eclipse IDE for Java developers. And I'm going to specify Java 11 and say install. I don't know where exactly it's going to install it. but when in doubt, have zebra cakes and cappuccino.
I really want a zebra cake. That sounds so good.
They are really, really good. They're underappreciated in my opinion. Alright, I'm going to launch this. So how did you create the JFrame? We're going to create it again, so we'll get a chance to see. So we'll go with this default workspace. And we'll say new Java project. And we will call this GUI 3. And we'll uncheck this, but it's saying Java 11, which is what we want. Alright, so how do we create the JFrame? I'm going to right click on the project. I'm going to say new. I'm going to come down to other. I'm going to have to install this stuff again. We'll do it quicker this time. There is a dark mode, but so one of my small complaints about Eclipse is it feels difficult to customize, and even if you do get it customized just the way you want, when you change workspaces, those customizations go away. And you can save those customizations in a file.
That is so silly. Come on.
Yeah, and you can save those in a file and restore them, but that only seems to somewhat work. And it's pretty easy by messing around with the color schemes to accidentally get into a state where, for example, your menu prompts and your background are the same color. And it's really hard to get out of because you can't see your menu prompts anymore because they're the same color as the background. And I haven't had a lot of joy, so I usually just let it burn my retinas by doing, you know, bright white and live with that.
Code has like 25 different default colors that all have proper contrast and whatnot of menus and whatnot.
Yeah.
You can like download more, like probably millions.
Yeah, yeah. Alright, so let's try this again. File, I'm going to right click on the project, I'm going to say new, I'm going to go to other, I'm going to come down to window builder, expand that, go to swing designer, expand that, and then do JFrame. Give it a name, I'm going to call it main, and I'll say finish. And that should get us our basic code, which is enough to get a JFrame up when we go ahead and run. And the X button suddenly works properly because we've got this default close operation. Alright, so now let's try the design tab. And this is what we were hoping to see. So let me change the sizes of this. So this is our JFrame, right? This is the thing that happens when we go ahead and we run our project. We get a window, it's, you know, at this location, pretty close to the upper left corner. If I come in here and I make this window taller, maybe I'm on the wrong window. And then I run this, and I'll say always save resources before launching. Right, now I got a square window instead of a rectangle. So this is a basically one-for-one, right? What I see here should be what I get when I run. Does not always work that way, but that's the goal. All right, so properties. So there's a hierarchy of components. This is a JFrame, right? It's also got what's called a content pane inside. That's this business down here where it created a J panel called content pane, set a border, set a layout, and then added that to the current frame. But let's just look at the JFrame itself. So this is, right, a component of type JFrame. And we can you know, change the default on close operation. So I could say, you know, do nothing on close. And now if I look at my source code, the default close operation is do nothing on close. So we'll put it back to exit on close. And this is part of why GUIs are popular, right? Because you don't have to actually write any code. You can just point and click, right? It's like playing a video game, and you've got code at the end. So we could put a title in here, right? My super amazing frame. And so now you can see that title showed up here, and if I run this, right, I'll get my window, and it's called my super amazing frame. And so you can play with these different properties. There's a background, so for example, you know, background has 3 numbers. Well, those are colors, red, green, and blue intensities. We'll talk about those later, but I can also click this thing to the right of it and bring up a palette. And I could say, oh, I want my background to be red, because, you know, everybody loves red. And now, you know, the background of my frame is red. The whole thing's not red because this thing in the middle, this is a content pane. And it's sitting on top of my frame, but the frame itself is red. And if I run that, you know, get a red frame. More or less.
I'm not really seeing the red there.
Hey, you know, more or less. All right, so yeah, less on this case. So you can click this button down here and see advanced properties, and you can get more options that you can set, including changing the font. So we can go with, I don't want to mess with fonts too much. You know, we can make a big font. And you can change foreground colors, and you can change the icon that's used when you iconify and stuff like that. And not everything that you set in here is going to necessarily show up in here or show up when you actually run. Because there's a lot of interaction going on between a lot of different pieces of this system. And so this is one area where sometimes it actually is going to be helpful to do some Googling. But not for every single thing you want to do. All right? If you're in a state where, hey, I'm trying to set the focus up to this widget, and when I type, I've set up an event handler, but for some reason when I type it's not responding, that's a good thing to Google, right? Because there's some peculiar things you have to do once in a while. But not for the stuff we're going to do to begin with. All right, good question. So Eclipse and Git do play nicely together, as nicely as anything plays with Git. You can set up a Git repo and interact with Git through the Eclipse interface. I don't do this. When I'm using Git, I want to be using Git, right? And I don't want a middle layer in between. But sometimes you'll be working on a project and the instructions will be, you know, we're going to do this under Git, and here's the repository, and set up Eclipse to work with that repository. And then, you know, you'll have a Git window that can pop up, and you can hit a push button or a pull button, and so on and so forth. I'm not going to go through that in here. That's a whole course in itself. But it does play pretty well with Git. But, you know, your other option is go into your whatever your workspace was, and do your git init here, right? Or maybe one level up, and just treat it like a plain old directory. All right, so we can set different properties. That aren't red. Oh well. All right, we're going to want to make, interfaces with buttons and drop-down boxes and so on. So we can pick different objects from here and add them to our window. So components are the things that people will mostly interact with: labels, text fields that you can type into, buttons that you can click, radio buttons where you can choose one of a number of them, password fields where you can type and see asterisks instead of the letters, and so on. And we can just grab these and drop them into this window, and build up an interface this way. But IDEs always want to run your life for you, and so there's always a layout manager. And by default, right, if I put a button in here and I drop it right here, it's not going to end up right there when I actually run my program. It's going to end up somewhere else. Because where you place things in this field by default are not where they end up. There's a manager that's moving your components around for you. For good reason, right? If I place my start button right here, and my stop button right here, and my go button right in the middle, and then somebody runs this on a system with a much bigger display, and they try to make this frame really, really wide, I'm going to have a button here, and a button here, and a button here, and all this empty space over there. And usually when you have a graphical program and you run it on a different size display, you'd like it to still look reasonable. Right? If I have 3 buttons spaced evenly across the top and I make my window bigger, I'd like my buttons to still be evenly spaced across the top. And so there's code running as part of the JFrame that will help us figure out where to place these buttons. But for learning this stuff, I think that's a pain. I think it's a distraction. So we're going to click on Absolute Layout. I'm just left clicking, and I'm going to come in here and I'll get this little green border, and I'm just going to left click again. And that's going to add what's called an Absolute Layout Manager to this frame. And now whatever I place in here, that's where it's going to sit. So if I left click on J button, release the mouse, come in here and drop it down, there's a button. If I left click on J button again and drop one over here, there's another button. If I left click on J label and bring it in here, there's a label. And if I run this, this should be exactly what I get. New label, new button, new button. I'm going to get rid of that red color because it's just bumming me out, you know. On the frame. Alright, that's better. Alright, so each of these things is an object, right? All of these things are instances of classes. So a new button, right, this button down here, it's a variable called new button, but it actually comes from the class javax.swing.jbutton, which if I hover I can see the whole hierarchy. A JButton is an abstract button, which is a component, which is a container, which is a component, which is an object. If I click on this button, I can come in here, I can set the properties for this button. So this one we may be able to set the color on. Set that to red. And when I run it, now I got a red button. Not the red buttons, but you know. Alright, I can change the label. So let me go back to non-advanced properties. So text, I can say, you know, this will be my launch button. That's why it's red. And this will be my lunch button when I get hungry. And my label, I can set the text and say, you know, this is my main control panel. And, you know, it shows up main C ... Why? Because my button's not big, my label's not big enough. So I can grab a corner and make it bigger. And I can move it over. And so now I've got a pretty boss interface going here with a launch and a lunch button. Alright, this is going to be basically what we're doing for the rest of the course. Well, not just this. Now, as we're doing these things, code is being written for us by Window Builder, right? This is our program right now. It's got all this stuff going on, right? Made a new J button with a label of launch. It passed that to constructor. It set the background color to red. It gave it some dimensions and location, and it added it to our content pane, right? Which is this thing called a J panel. And then here's another button called button new button _1, which is the lunch button. And here's a label, which is the main control panel, and so on and so forth. Is it possible to create an object of type Java? I don't think Java is a class. So I think if I said Java space object name, it would compile error. This tends to be a lot of fun for most students. It's a whole lot more control than what we could have dreamed of with a dialogue script in 224. The depth of the rabbit hole you can go down with this is staggering. And, you know, as time permits, go down those rabbit holes, explore these things. I mean, just something like a button. If we turn on advanced properties, there's a lot of things that you can tweak in here, right? There's also basic things like we can uncheck this enabled button, right? And when we run our code, this button's not clickable anymore, right? Why? Because it's not enabled. Well, how did it end up not being enabled? Because a piece of code was generated that said set enabled parentheses false. Why was that generated? Because I unchecked this enabled box. If I check that to say true, that goes away and now the button's enabled. But inside our code, we could also say, you know, when this happens, let's set enable to false, and we can disable a button while our program's running, and then re-enable it later.
Was Eclipse written using JFrames?
I don't know what Eclipse is written in.
In Java?
I would guess, just looking at the error message that we got from Window Builder, this is certainly Java, and it's certainly the Swing Windowing Toolkit, I believe, SWT.
Java and C.
Yeah, probably mostly Java.
Yeah, because the frames that you're making look similar to the frames that the Eclipse is.
Yeah, it does.
Actually identical.
And I think Eclipse is open source? I don't know. Eclipse is an open source community whose projects are focused on debugging.
They got a GitHub.
Yeah.
Oh no, they don't have a GitHub. They have a weird Git repository thing.
Yeah, it's programmed in Java. So, I mean, you can pull down the source code, presumably, and go to town with it.
Ruining it.
Improving it. By the way, if you want to dig into some Java code to, like, you know, get your 10,000 hours,
10,000 hours for what?
10,000 hours of coding. That's the rule of thumb benchmark for how long it takes to become proficient at something, whether that's playing baseball or tennis or coding or playing violin or whatever. So 10,000 hours of coding.
You have a labor log that's due by the end of the course, and you have to track all your coding hours, and you have to have at least 1,000 to pass the course.
Yeah, that would
One
be
class?
no.
Oh, this one?
Yeah, in this class, you have to keep a log of how many hours you spent coding, and you need at least 1,000 to pass.
Yeah, that would be super fun.
Does that have to be class related? I mean, I've got probably like, I have no idea, but
Yeah, we're not being serious.
no, I know.
Yeah. So the assess command is user local bin assess. Has anybody looked at that?
The access command. Oh no, I haven't looked at it.
So it's a bash script. How horrifying is that?
Not really. I don't think.
So it's copyrighted, but
Copyrighted it?
well, it's under Creative Commons, but you can't really state rules under which this can be managed unless you own a copyright on it. So open source licenses are built on top of copyrights, basically.
Oh, you did. That's kind of cool.
Yeah.
How
So
big is this?
it's not big. It's 80 lines, you know, with some comments in it. But the real guts of it is once we get past all the things that you can get yelled at for. The real guts of it is just a Java program. And so it executes these classes from a jar file called assess.jar. And it's just a big Java program. And assess.jar really links to /home/nic/assess/assess.jar. And if you look in here, there's all the source code for the assess command. So assess.java is the main class. And that's 225 lines. But this is what happens when you say assess. So there's your menu options. The other menu options have been commented out. And so, I mean, if you want to figure out how assess works, the source code is all there. And sometimes it's fun to look at source code and figure out how something does what it does. And, you know, if you find the bugs in here that let you exploit this and give yourself 10 out of 10, then you deserve 10 out of 10. But this is mostly stuff that... Yeah, go ahead.
Do we, though, deserve 10 out of 10, though, for doing that?
I would be pretty excited if people found bugs in this.
I want to know why it's 10 out of 10 and not 1 out of 1.
Because it used
I've
to...
never gotten anything other than a 0 or a 10, so I feel like it should be a pass-fail type of thing.
Well, but it used to give you grades. And there's one line of code in here that if you uncomment it, it'll give you from, 0 out of 10 up to 10 out of 10, but it'll give you partial grades. This was originally written to run a series of tests, and some of the tests were graded, some were not. So you could run the ungraded tests, and then you could run the graded ones. And if there were 5 of them, they could be worth different numbers of points. The problem was that unless I was very careful with designing the questions, you could assess something that did almost nothing correct and still get like 5 out of 10. And some people said, that's good enough. right? Because assess was only worth 10% of their grade, so if they get 5 out of 10 on each one, they've only lost 5 points. And so people stopped putting in the time to really sort of figure out those last details on each assignment. And that was really what I wanted people to do, was make sure they really understood whatever the key concepts were. So a few years back, I just changed the grading to be like binary. But so now you know the history of the 10 out of 10. You can like amaze your friends. All right. And the other stuff should be locked down. All right. So this is all going to be Java, right? And we're getting lots of code written for us, but it's mostly through drag and drop interactions. And so we can set properties over here, which are mainly look and feel or basic behavior. But if we right-click on, say, a button, we get another list of options. And one of the options we get says Add Event Handler. And with this list, we can choose what we want to have happen in response to certain events, right? So we said we're doing event-driven programming. So for example, we could say, hey, when the mouse enters this button, I want to have something happen. So I can left-click on this, and some more code gets written. And I can add some code here, like system.out.println. You just entered the button area. And I could add another method over here. So I could say add event handler, and I could go to mouse, and I could say mouse exited. And I could put a message over here.
Yeah, question.
Yeah.
So we say mouse event E as an argument inside of mouse enter or mouse exit.
Mm-hmm.
What is in that E?
So mouse event is a class in Java. And it's got some static fields defined, button 1, button 2, button 3. It's got some methods like getButton. So I could say, since we're calling this and we're passing a mouse event E, I could say e.getButton, and it will tell me which mouse button was involved in this event. I could say e.getX, and it will tell me the X coordinate related to this mouse event. And we're not doing anything with this right now, we're just putting in a print message. But if we were doing something like responding to a mouse click, we could actually find out where in the button the person clicked. Did they click with a left button, a right button, or a middle button? Did they click with a modifier like Shift or Alt being held? Right? We can ferret all of that out from this object, which is passed to this event handler, basically an interrupt handler. For now, we'll just print a pair of messages. And let's see if this actually works. So without clicking, I'm just going to move the mouse over my button, and I got a message saying you just entered the button area. And when I leave, I'll get another message saying you left the button area. And so I can do this kind of thing, you know. And this button, I haven't set up any handlers for those events, but this button I did. Now nothing happens when I click it because I didn't specify a handler to be called when the button gets clicked. But I could do that. So let's go with the launch button, and I'm just going to double click this. This is a shortcut for setting up that handler. I'm just going to double click it, and it's going to bring me into some code which says action performed. And I'll put a message in here. I'll just print a message saying this button has been clicked. So when I run this, if I enter or leave over the launch button, right, I can run some code. Nothing happens when I enter or leave the launch button, but if I click it, I get a message saying launch button has been clicked. I'm right clicking and that's not activating it. I'm middle clicking, that's not activating it. I'm control left clicking, I'm shift left clicking, and those are activating my method. So let's look at this action event. So here's one way we can play with being in an IDE. Let's just say arg0 dot. And I see a window of things that I could call, methods I could call on this arg0 object. Why? Because it knows arg0 is an action event. And it knows what action events are. So there's some static methods, and I can toString and all kinds of source. And so if I'm versed in action events, I could find out, for example, the XY coordinates where this click took place. But we got to do a few things before we're at that point. All right. So here's a convenient thing to keep in mind. Sometimes Window Builder breaks. So I'm looking at my design window. I'm not seeing my buttons and stuff anymore, right? They seem to have vanished. Go back to your source code, right? And I started to write some code here, and I've got a syntax error. When Window Builder tries to show me what my frame is going to look like, it's basically executing my code. And if my code has errors in it, it can affect what I see here. So the fact that I have this syntax error right here, because I was just playing around with this, that's stopping the system from showing me my frame. So if I just comment this out, right, and then I look at my design tab, I should be back to seeing my buttons. So let's look at this main panel right here. So this is my content pane. That's a J panel. Let me go back to simple properties. Right, the class comes from J panel, and J panel is another swing component, and it's, you know, inheriting all these things from all these other classes. So let's right click on here and let's add an event handler, and let's go down to mouse, and let's go down to mouse motion, and let's do mouse moved. Alright, so this is going to be a mouse moved mouse event. And remember when we looked at mouse event, there's a method called getX and a method called getY. And they return the horizontal and vertical positions of the event related to, in this case, mouse motion. So let's add a print message here. So I'm going to say x equals, and I'm going to do e.getX. I'm going to say y equals, and I'm going to do e.getY. So I'm just going to put one print message in here. And the idea is whenever the mouse moves in that J panel, this method should get called. And it will be passed an object, which is a mouse event object called E. And if I call the getX, getY methods on E, it should give me the XY coordinates related to this motion event. And so this should let me see where in the panel my cursor is in terms of XY. So if I come in here, you can see I'm getting XY coordinates every time the mouse moves. Upper left is close to 0, 0. There's X increasing, and here's Y increasing. If I'm outside, nothing happens. If I'm on the title bar, nothing happens. If I'm inside a button, nothing happens because the button is capturing that mouse motion event. But in the panel itself, I'm running this little piece of code right here every time that my mouse moves. And I'm not clicking, I'm not holding, I'm not dragging. I'm just moving the position of the cursor. Alright, so our next challenge is figuring out what of, everything that is swing is really interesting to us. So figuring out a few specifics like mouse motion in a J panel, responding to a button click, things like that. But getting some practice at looking up what we need to know to figure out how to use these different things. So, if this is a J button, we can look at the documentation for a J button, and we can see the methods that can be called and so on. And then the main challenge is figuring out how we're going to put these things together to do whatever we want to do, starting with PA4, which we'll talk about on Wednesday, and I'll post up probably sometime tomorrow. But this is enough already to get us on the air with some non-trivial examples of basic interactions with a GUI. So we'll keep building on this. We'll go through a few specific things like labels, buttons, checkboxes, radio buttons. We'll dig a little bit more into what's going on with some of this code because there's some really kind of odd stuff going on in here. If you really break apart the syntax of this, it's pretty bizarre. It's something called an inner class. It's a great shortcut. It's done for us, in this case, by the IDE. But we'll talk about inner classes a little bit. And then we'll just start building up some cool applications. And then eventually, probably also on Wednesday, we'll talk about painting. And if we want to actually draw things by, lighting up pixels or drawing line segments or circles, how we can do that. And that's a bit of a peculiar thing to do, but it's pretty standardized across different platforms. The way we paint here, the way we paint in Android Studio, and so on, will be basically the same. And I will probably, after tomorrow's class, overhaul my interface and change the font and add VI to it and so on and so forth. So if you're interested in customizing this, come by office hours. And I don't want to do a lecture on how to customize Eclipse, but basically under window preferences, you've got all kinds of options. And when your preferences has a search bar included, you're playing with fire. So if I want to change my font, I can say font, and there's a few different places where I can change that. Most of what you might want to customize is doable. Some things are not. For example, you cannot turn off automatic indenting of new lines, no matter how hard you try. No matter how many times you check or uncheck the boxes that say do not auto indent, right? It'll still auto indent for you. So if you go with VWrapper to do VI, that problem goes away. But mostly you can customize the way you like. All right, so mess around with Eclipse, play around with some swing stuff, get some JFrames up. ODP 306 is due Wednesday, not Tuesday. Obviously finish up PA3, and we'll move on from here on Wednesday. All right, have a great afternoon. I will see everybody next time. Thank you.
Thanks, bye.